It is the last educational meeting of our engineer season. And with that, we just wanted to congratulate Damon Monty for being our president for the 2020-2021 season. We appreciate your leadership during this crazy year as virtual events. And we were talking earlier that you kind of got off the hook speaking in person. So lucky on that. But thanks to our whole leadership team, our Vice President Josh McCombs, along with Daryl Berry, our Secretary Treasurer. We'll be meeting again in September and we'll have the summer off here. With that, I'll toss it over to Damon.
All right, thank you. Well, it's been a unique year, to say the least. To have a full year of completely virtual meetings, that's had its share of challenges, but I think it's actually been pretty successful. The wide range of topics, expertise of those topics, they've all been excellent. And everything we expect here at the BOMA Minneapolis Engineers Association. But I want to personally thank everybody involved in these presentations over the last season. There's no way we could have done this by ourselves. So thank you very much, everybody who's been involved. You've all helped immensely. They kept us focused, we kept us informed, most importantly, kept us positive while looking into the future. So thank you. One of my personal goals this year was to get more comfortable in front of people. And as I host this meeting and look at myself in my computer monitor in an empty office, I'm thinking this is a piece of cake. So I joke, but I'm really excited to have in-person meetings again next year. Before we get on to today's presentation, I have a couple of announcements. The registration is open for May BOMA Ed session, Thursday, May 20th, with knowledgeable panelists, current members of ours, to speak on lessons learned over the past year and some of the best practices that's developed. Remember, all engineers are welcome to attend both engineer and the general meetings. So as we talked about before, this is our last educational meeting for the 2021 Engineers Association meeting cycle. Our annual social, which is usually held at a local brewery, is scheduled for June 2nd. However, we're waiting on confirmation to see if this is an option. But we'll keep you updated on our communications. Thank you to our Engineers Planning Committee for coordinating this past year's monthly meeting topics and sourcing speakers. We hope to be back in person for upcoming year. That would be September of 21, and we'll be meeting monthly until May of 22. Now I'd like to introduce today's speaker, Peter Roshimkovich, building envelope and restoration consultant with Walker Consultants based out of the Minneapolis office. Peter has over a decade of experience in forensic investigations, property condition assessments, as well as the design and administration of building enclosure and restoration projects. His restoration experience includes remediation of new construction defects, repair and maintenance of aging structures, and restoration of historic properties, including several landmark buildings. He's an active member of the International Institute of Building Enclosure Consultants and has previously held leadership positions in ASCE and ASTM. Peter is a licensed professional engineer in Minnesota and New York and is also a registered roof observer. While he's presenting, please, anybody who's watching, you can use the chat function or the Q&A function if you have any questions. I'll monitor them, and if anything comes up, we'll answer them. We appreciate you taking the time to present today. And with that, I'm just going to hand it over to you.
Great, thanks, Damon. Appreciate it, and thank you for having me. Excited to present for my first time here, at least. As kind of mentioned, or in the kind of brief synopsis, so I plan on talking a little bit about the roof anchors that are used for facade access. So commonly used, especially for building maintenance operations or during repairs, things like that. So yeah, if you have any questions, please feel free to let me know. Hopefully everybody's seeing my screen pretty well at this point. So that's it. So for the presentation today, I plan on just going over some of the common applications of the roof anchors, our general, kind of like a general overview of what they are, how they're used, when they're used, things like that, and the most common times that they're used. We'll go over some of the relevant codes. Specifically, we're going to go over the OSHA requirements for these. We'll also be going over the Minnesota specific regulations for these, and also updates to the International Building Code that have been made recently. So go over all of those. And I think, you'll see that we're going to have a lot of topics that we're going to go over, or a lot of applications these can be used. The one we're going to dive into most is going to be rope descent systems. Where most commonly, this is really window washing. So we'll go over what are some of the main requirements, kind of what to be looking for when hiring a window washing crew, what they need to be doing, some of the safety procedures they need to be following while doing that. After we talk about that, we'll get into annual inspections. So just some of the things that we're looking for when we do these annual inspections. Then we'll talk about how these anchors get certified and recertified at least every 10 years. And then finally, we'll get into a little bit of anchor replacement in the event that, in the event that we see a failed one or you need to replace it for whatever reason. We'll kind of go into that a little bit. So the first thing, what are roof anchors? So roof anchors are devices that are installed on the roof of a building that is designed to serve as an anchor point for a fall arrest system. And a fall arrest system,
I apologize to interrupt here. We don't see your slide deck up. I'm not sure if you shared your screen.
Oh. How about now?
There we go. Good to go.
Okay, sorry. Nothing too important on my previous slides. Kind of just went over the agenda a little bit. So what are roof anchors? Thanks for that. So roof anchors are, as I mentioned, just devices that are installed at the roof to serve as basically a restraint system for a fall arrest. So anybody who's working either on the roof or actually doing the actual facade work on a building as well. These are the points that you're going to tie into, and that's going to basically provide that last line of defense to make sure in the event that you fall, slip, if you're in a bucket, if you fall out of that, or if the bucket gives out beneath you, this is kind of providing that last line of defense. So you'll see we have a few different anchor types over here. Kind of you can have these things installed into a parapet wall over here, like a side-mounted anchor. A lot of times you'll see them installed directly into the horizontal surface as well. Some other items as well, you can kind of have these cable systems. This is more commonly seen on pitched roofs or sloped roofs. So you kind of they hang a cable across and you tie into those. They make specific ones for standing seam metal roofs as well that you can do. They kind of have these portable ones as well that are sometimes used. My experience more is kind of with these first two over here, a little bit of with this other stuff. Some of the other things that we'll also kind of talk about a little bit, we'll talk about davit structures, which are like the permanent installations of the building to access the facade of the building. And yeah, the testing of those as well. So as we said, what are these really used for? So kind of these are some of the more common ones. You have rope descent systems, which is really the window washing items that you have, or typically you'll have a bosun chair underneath, also supported as well. You can use these these are used as lifelines for industrial rope access. So this is kind of been a growing field lately, especially for facade inspections and things like that. So even though these look very similar, there are some differences and they do have some slightly different requirements for the people that are using them and doing the work on those. And then also we have, swing stages, suspended scaffolds. And so even though the scaffold is usually supported by an outrigger structure and kind of weighted down on the roof itself, the lifelines that are actually holding the people in, which you can kind of see right here and here, these are typically attached your lifelines are tied and attached to those roof anchors themselves. And here's another little graph that I found online. So you can see that, you know, usually you'll have to have, everybody will be attached to their own independent anchor. So you won't see like two people, they can't attach to the same one. Or even if you have, for example, a window washer, their chair is going to be attached to one lifeline, or attached to one anchor, their lifeline is going to be attached to a completely separate anchor. So that way you always have kind of two independent anchors that are providing you double protection. You're not tied into the same one. So in case, you know, one gives out, you still have another backup there. And kind of as I had mentioned before, you can see this is a swing stage right here, which can be attached, you know, in this case it is showing to a wall, but usually you'll see these are weighted down with some weights as well. But the lifeline itself will always be independently attached to the building. So we'll go over some of the relevant codes. So here are just, here are some of the main codes that are followed, regulations. So obviously we have, there's a Minnesota specific rule for this, 5205.0730, which specifically addresses window cleaning and maintenance. We have a few different OSHA regulations. We, as of the 2015 International Building Code, these anchors are actually now part of building code requirements. So in the case of Minnesota, where the IBC 2015 was actually never adopted, that means the 2020 code was the first point where this became codified. And then the last one, which I kind of have as a, you should see I put it in a slightly lighter font, is the ANSI IWCA, the International Window Cleaners Association, I think, which published a guideline back in 2001, which for many years was the kind of the industry standard that a lot of people referenced and used. And you'll even see that OSHA references these things sometimes. That's kind of because it hasn't really even been updated since 2001 or recertified. And you're seeing, you know, greater enforcement from OSHA and the building code. That requirement's kind of fading to the background. And so really kind of these three that I've highlighted here are the main codes that we have to follow. The Minnesota code, there's a specific OSHA 1910.27 for scaffolds and rope descent systems. And then the Minnesota code, which even though it only went into effect in April of last year, moving forward for any new construction or kind of any modifications to buildings, if you're installing new anchors, this would be the one that's probably going to be followed the most. And some of the other ones are adjacent kind of codes, like the personal fall protection or powered platforms. They'll have code, these sections will typically reference 1910.27, or they might have a couple of other things that are specific to those items. Those would be things like the davits and swing stages and things like that. So a brief history of specifically the code in Minnesota. So OSHA has been requiring the testing of these roof anchors for a long time. But it was kind of one of these things that, even though it was an OSHA requirement, was never really enforced too much. And then there was kind of like a series of accidents in the late 2000s that kind of brought this issue to the forefront here in the state. So, you know, in December 2007 was a pretty high profile case at the IDS Center in downtown. And then, you know, March 2009, we had another worker fall in Bloomington, and then a couple other incidents in St. Louis Park as well. As you can see here. So all of those items combined in a relatively short period of time led to Minnesota passing Part 5205 and .0730, which was the window cleaning and maintenance, building maintenance, which was adopted in March of 2012. So just over 9 years for that. And that'll be important for a little later on when we're talking about recertifications, which will be coming up, which will most likely be coming up for a lot of buildings. So what does that Minnesota part rule, what does it really say? So this standard really applies to all window cleaning operations, building maintenance operations, or a combination of both that is performed on the inside or outside of a building, structure, or skyway when that work is performed at a level that is suspended more than 14 feet above grade or an adjoining flat roof or other flat surface. This requirement does not apply to a window washing operation or building maintenance operation that is performed from grade level or from a ladder supported at grade. So the intent was not to bog people down with, these super minor things that, you're getting a ladder and just taking care of a minor thing, but it is supposed to be something in place for when you're doing a full building-wide maintenance campaign. And then the other thing that's important with that is, if the access is supported at grade, then you won't need to worry about this too much. So if you're renting a boom lift, for example, to do some building maintenance, ladders we mentioned, those will be fine. Although, especially with those things, you still have to follow other OSHA guidelines. It doesn't give you a free pass to just ignore those as well. Those still apply. And then the other thing that's important with this is that it prohibits rope descent systems, the window washing, from being used at heights greater than 300 feet unless the qualified individual can demonstrate that access cannot be attained safely and practically. So if your reason is it's more expensive to do it, that's not really going to be an acceptable reason. You've really got to show that this is the safest way to do it, and anything else will actually be more dangerous to do. So part of the rules that, so this rule kind of puts a couple of requirements on both the owner of the building and also the employer or the company that you're hiring to do the maintenance or do the window washing, things like that. And the first thing that you have to worry about is going to be the employer or the person who will be kind of responsible for the work being done. They must provide a written plan to the owner, and they must review it with them before the work starts. And so that written plan basically is going to say things like the location of the work, where workers may utilize suspended equipment or where workers may be exposed to falls or other hazards. It can talk about, it has to identify any hazardous areas or drop zones and any safety features that'll be used. It's also got to talk about a self-rescue plan. So what to do in the event that, if it's a swing stage or whatever gives out and they're hanging, because when you're using those harnesses, usually you only have a certain amount of time before actually the circulation will get cut off, and you have to, it buys you time, but you still have to be rescued within a certain amount of time. A step-by-step procedure on the control of each hazardous area. So how are you mitigating any of these risks? And an on-site evaluation of the plan by the employer or a qualified individual. The other thing that the employer must do is they must perform a visual inspection of the building exterior. Basically, the things that they should be looking for are going to be like ledges, sharp edges, anything that could potentially interfere with the rope getting stuck on the side of the building, or abrading or getting cut kind of against that is one of the things. And one of the things, you identify those areas, and then the employer must provide some kind of padding or something that's going to mitigate the risk of the rope getting cut or damage to the building as well. The other things the employers must do is provide fall protection for all of their workers. So these are the things like the harnesses and the rope grabs and anything else that is going to be specifically required for that plan for the workers to perform it safely. And then finally, all of the workers must be trained. So you can't just send somebody out and tell them to go down the side of the building without any training. The owner also has some requirements as well as part of this. So the owner is going to kind of prior to the start of the work, the first thing they want to do is hire a competent contractor. So, obviously there's always a race to try to get a cheap low bid, things like that. But it's kind of on the owner as well to ask the questions of the contractor they're hiring. Do you have a written plan? Have you done your building exterior inspection? How are your workers going to be trained? Do you provide things like that for all of them? So that's one of the requirements of the owners. And the other thing, as kind of mentioned, is you do have to review that written plan before the work starts. So you have to make sure it's there and it's been addressed and it's being done. And then the final thing is you have to provide written documentation to the employer that all of the anchors have been certified and that they have been inspected within the last year by a qualified individual. So somebody experienced, specifically experienced in roof anchors and things like that. So that was the Minnesota code. And now this is the OSHA requirements that is going to be used most. So before any rope descent system is used, the building owner must inform the employer in writing that the building owner has identified, tested, certified, and maintained each anchorage so it is capable of supporting at least 5,000 pounds in any direction for each employee attached. This information must be based on an annual inspection by a qualified person and certification of each anchorage by a qualified person as necessary and at least every 10 years. So I just want to emphasize that last part of that sentence, and at least every 10 years. So if you have any reason to think that your anchors have been compromised, this can be something such as there's been, there was, heavy mechanical equipment that bumped into it, maybe when they were setting it. If there's been a lot of roof leaks, things like that, that may have started to cause corrosion. Or if you know of a couple of anchors that have already failed, then this doesn't give you, you can't say, oh, well, I've still got a couple years left. You do have to do it as if you have any reason to believe that it's been compromised as well. And then the other thing that this does, that the Minnesota code doesn't necessarily say anything about that 5,000 pound requirement. It just says it needs to be inspected kind of as annually inspected and within certification. So some of the requirements, so for the employer, just the main one is you don't want to proceed until you have that annual inspection and you know that it's certified and that certification is still in good standing as well. From the owner's perspective, you have to provide that annual inspection by a qualified person and then perform that certification test as necessary and at least every 10 years as well. So now we'll go into rope descent systems. So again, these are the window washing. This is specifically for window washing. So I had talked a little bit about how you want to make sure you're hiring a competent contractor, somebody who's following all the rules. And so this is actually in both Minnesota and the OSHA requirement is that the employer must be keeping a written log on site every day following all of these particular steps. So it's kind of like a little checklist that they keep, and every day the foreman or the kind of lead person on site, the competent person, will be signing it saying that they've followed all of these steps. So ensure the use of equipment according to the instructions, warnings, and design limitations of the manufacturer and distributor. So they should familiarize themselves with the systems that are being used, whether that be any motors that they're using or the specific anchors. If there's anything, we had talked about, there's those cable systems, or maybe if it's a tilt over anchor, possibly, they should be aware of what these things are. Inspect the equipment and every rope descent system prior to its use every day and remove damaged equipment from service. So they're looking for things like, how is that rope in good shape? Is it starting to deteriorate? Are they seeing kind of like bird caging or fraying, things like that. Inspect equipment after each descent and when moved to a new area to ensure the rope descent system is properly assembled before descending again. All damaged equipment shall be removed from service. Ensure the use of proper rigging, including structural anchorages and tiebacks. with a particular emphasis on providing tiebacks when counterweights, cornice hooks, and parapet clamps or similar non-permanent anchorages are used. Ensure the use of a separate, independent personal fall arrest system with a separate anchorage point. So that was that when I was showing some of those original diagrams and some of those original photos, just making sure that, you know, if I'm in a chair or if I'm in a scaffold, in a platform, those are attached at one point, and then my harness and my lifeline are attached to a completely separate point. So that way, if the stage falls out for any reason underneath me, I'm still good to go. And I'll be fine. And then another thing I also want to make sure is sometimes, usually those swing stages, for example, will be designed for 2 people, or they set them up for 2 people, and then you have an engineer or you have somebody come in and do an inspection, and now there's 3 people. Well, there needs to be a third lifeline. You can't have 2 people connecting to that one point. Ensure all lifelines are capable of sustaining a minimum tensile load of 5,000 pounds.
Sorry to interrupt, but a question just came in that relates to that. Is the 5,000 pound verified by a physical test or based on the design of the system?
Yeah, we're going to go into that a little bit later. So the answer is it has been based on design in the past, but there is physical testing that is involved as part of that certification. And we'll talk about that between 5,000 pounds and how in the past, a lot of times it's been maybe a little bit less, but we'll talk about that a little further.
Perfect, thank you.
Provide prompt rescue of employees in the event of a fall, which shall include self-rescue. So they have a way of getting out. They don't have to wait for somebody to come and save them. Ensure ropes are effectively padded where they contact edges of the building, anchorages, obstructions, or other surfaces which might cut or weaken the rope. I see this the most, I think, on parapet walls where you have maybe like a sheet metal cornice or something like that. You know, there's sometimes you're worried about the sheet metal that's cutting into it. So you'll put like a piece of carpet, or, you know, I think carpet is the one I see most often. Some just little padding there to make sure it's not abrading away. It's gonna weaken the rope. Provide stabilization at the specific work area location when descents are greater than 130 feet. So if you're in that kind of like 12 to 13 story range, this is when you have to start worrying about something like this. Prohibit window cleaning or building maintenance when the work area is exposed to excessive winds. Excessive wind is considered to be a wind which constitutes a hazard to the worker, the public, or property. This is a bit of a gray area, I know. I know some other municipalities have rules like 20 miles per hour specifically, sustained winds and gusts above 30. It kind of gets to be a little bit of a gray area, but obviously there's certainly a line at some point you don't want to cross with that. Require each employee to secure equipment such as tools, squeegees, or buckets by a tool lanyard or similar method to prevent equipment from falling. They should really be adding cell phones, I think, to that list nowadays. Not that I've ever dropped a cell phone 9 stories before. It happens. And then finally, protect suspension ropes and lifelines from exposure to open flames, hot work, corrosive chemicals, or other destructive conditions. This one doesn't come up, you know, not too many open flames really, but I think corrosive chemicals comes up a little bit, especially in the cleaning operations when you're using cleaners maybe for a stone building or something like that. Some of those can be pretty caustic. So these are just some of the things. So as we've mentioned, we have the annual inspections, which both the Minnesota rule and the OSHA rule require. And so once a year, you have to hire a qualified individual to perform a overall inspection of all of the roof anchors. Now, this annual inspection does not include any physical testing unless the qualified individual suspects that there has been that maybe one of the anchorages is not capable of performing its load. They see that it's moved, they see it's corroded, something like that. So even if you're not due for a certification, of course, that person can always say, well, I'm concerned about this one and we need to test it. But some of the things that we look for when we do these annual inspections is we're doing a document review. So we want to make sure we have the signed and sealed, the original signed and sealed drawings or shop drawings, or the structural drawings, wherever it may be located on the system, kind of how it's designed so that we generally know what we're getting ourselves into and what we need to be looking for. The drawings themselves should always be posted at the roof entrance, so that way any workers who are coming up there can have a chance to look at it as well, especially when they're doing that initial written plan or those initial kind of inspections of the buildings. Then once we check for those things, we typically will review the as-built locations with the design drawings just to make sure everything in those posted drawings is what is actually in the field, that, you know, in general, they're in about the right locations, that they haven't, you don't have one way over here, because there's some, usually they should be within a pretty tight tolerance, within a foot or two. That way you can cover all of the building and you're not going kind of too far out. We'll talk about that a little bit more as well. Then we do a visual review of the exterior exposed anchorages. When I say visual review, this also kind of includes I don't want to say physical testing because we're not testing loads or anything like that, but we will kind of tug on it a little bit or kick it to make sure that it's not moving under a general load. We'll go over some of the reasons we would take it out for, but we're just doing a general review so it looks okay. And then if we have a possibility, we also like to try to take a look at it underneath. If you have like if you have steel decking, you have an exposed ceiling underneath, we'd look at the connections underneath, see if there's any corrosion, any rusting, or if a bolt fell out for any reason or something like that. So what are some of the things that we would take these out of service for? So like I said, I think corrosion is one of the really big ones. If we see that it's not a stainless steel, or if it was a coated anchor and it's starting to rust out and corrode, that starts to give us concerned. And a part of that is we're looking for if there's possibly any water infiltration occurring, because usually the exposed anchorage will be above the roof membrane, but if there's any reason to think water is getting in underneath, that's actually where those adhesive bolts and those anchors are. So we may need to do an opening at the roof just to make sure it's dry and things like that. It usually doesn't happen, but it's a possibility. Anytime that it's actually subject to a full fall arrest, you have to remove it as well. So if you do have an accident at the building and somebody falls and it does its job, that's great. But then you have to replace it right away as well. We talked about chemical attacks. So especially in industrial settings, or sometimes near these mechanical rooms as well, some cleaners, some things like that, those can cause that corrosion to occur a lot quicker. And then any deformation. So if we see the anchor starting to tilt a little bit, or if sometimes that ring looks like it's had a lot of wear and tear for whatever reason, it's not really holding up, those can be some other things. So now we'll get into certifications and recertifications. So my apologies if this is a little light. I just highlighted the important part of this. So this is the OSHA standard that kind of talks about that, those recertifications every 10 years. And in terms of testing the anchorages, so OSHA themselves is usually they try to not make codes or requirements. They try to leave it up to the judgment of the workers or the engineers on what's going to be okay. So specifically here, what I've highlighted is they said, because the OSHA standard does not specify criteria for testing anchorages, the qualified person may utilize any scientifically valid testing criteria to determine whether an anchorage is capable of supporting at least 5,000 pounds per attached worker. In general, this means using criteria that would be accepted by an industry consensus group or that are certified by a registered professional engineer. And so this is kind of where that testing comes on from that IWCA original standard. They're the ones who actually really called out testing the first time around. And that's what has become the industry standard for that. So those would be for prior anchors. The current building code actually does require all new anchors to be designed for a service load of 3,100 pounds and a design load of 5,000 pounds. And so what that means is the service load is basically what it could realistically expect to undergo. And then the design load is any factors of safety as well that are added on top of that. So it's kind of been, I've heard a couple of theories on why 3,100 was chosen. 5,000 has been the standard for so long that I've heard people say, well, they just divided it by the safety factor 1.6 and got to 3,100. And then the other one that I've seen is that this is the approximate force that would be caused by someone weighing, I think, like 310 pounds falling 6 feet. So, and that's 310 pounds, that includes any equipment and tools that a person may be carrying as well. So either way, 3,100 is that requirement. And this is going to be that requirement moving forward. Any work basically permitted after April 1st, 2020. So it probably doesn't apply to most buildings yet, but and the other thing that the code requires now is you have to have proof of that 5,000 pound design load. And as we get into the previous one, you'll see how previously, you know, the industry, a lot of people in the industry have been using 2,500 pounds as the testing requirement. So before 2015, these roof anchors weren't actually in the code. So this was really all left up to an OSHA workers requirements and also in the Minnesota code, for example. And so the old IWCA was designed for 5,000, specified 5,000 pounds. However, that specific standard allowed for the anchors to be tested to 2,500 pounds in lieu of full capacity. And OSHA even commented it, I have the letter highlighted, that this 2,500 pounds would be acceptable to them. You know, as an engineer, it gives me a lot of hesitation to certify something for 5,000 pounds when it's only been tested to 2,500 pounds. Just being around the industry long enough, you know, you hear stories of people who they've tested 2,500 pounds, no issues, and then, you know, they came back and, you know, as the industry has accepted that 5,000 pounds as it's starting to require it more, that 5,000 pounds, you know, it starts to fail at 4,000 pounds or something like that, which gives you a very small factor of safety, and kind of is concerning. And that's really been the growing industry standards now, particularly amongst engineers, is if it's been designed for 5,000 pounds, it should be tested for 5,000 pounds. There has been a lot of pushback to this, I think, especially from suppliers who have always wanted to do 2,500 pounds. I know one example I've had in the past where the specific anchor that was used, the manufacturer wrote a letter saying that, you know, you can't test it beyond 2,500 pounds because we require anything, if it's ever subjected to a load greater than 2,500 pounds, we require it to be replaced. So it can be a little bit of a gray area. Sometimes there are justifications for only testing to that 2,500 pounds. However, definitely as I think this next batch of certifications comes around, I think 5,000 is going to be required because, you know, that's what you're saying it can withstand and it should be tested to that. And then this is the rule for rope descent systems, the window washing. And then if you do have anchors that have been certified and tested to that 2,500 pounds, and you're using it for suspended scaffold, swing stages, lifelines, davit lifelines, or industrial rope access, the sprat, then you can still use it, but the user, the person who's going to be doing it, should be advised that really when you're kind of working yourself back, that it's really only been tested for a 1,250 pound service load. And so if that's the service load it's been tested to, then your safety equipment that you have, your harness, your lanyard, all of that is typically designed for an 1,800 pound force. So those people should be notified that it has only been tested to 2,500 pounds, and therefore all of their safety equipment should be limited to a 1,250 pound maximum arresting force, which it's just not the typical standard. Typical standard is 1,800 pounds, but it's really not an issue to get down to 900 pounds. They're pretty readily available. So it's not too much of an issue, but it is something that you should notify. You should notify the user, the employer of those people, what's going to be happening. So now we'll get into a little bit of how this testing is actually done. So the first kind of test that's pretty commonly done, especially for these horizontal roof anchors, is a lateral pull test, where you'll have two anchors and you'll essentially pull them. You'll pull them against each other to create tension and basically get to it. And you're looking for no deformation. So you're not looking for this to start tilting over here or over there. You're not looking, they should be completely still during the testing. And this creates a little bit of an issue because, as you can see on this one on the right, so right now what's happening is this hook is essentially pulling this roof anchor kind of towards the direction of the test. And what you have here is a plate that's mounted with 4 anchors. And so because this is pulling this way, the only anchors that are actually subjected to the force are these two over here. So what you want to make sure if you are doing these lateral pull tests is that you're testing in both directions. So when you're testing, like shown over here, you're testing this anchor and this anchor. And then if you were to put this on going the other direction, you would actually test this anchor and this anchor as well. So that way you have you're much more confident that all 4 of the adhesive anchors all the anchors are engaged and working, because, right now we're seeing the parapet, and typically the person will actually be hanging over this end over here. So there's a really good chance that it's really this anchor and these two are really going to be the critical ones. Although if they're off to the side a little bit, there's going to be a force applied to all 4 of them. So we talked about that, but then, sometimes that's not really a feasible test to do. And it's, like I said, it gives you more confidence and it's generally accepted. But another test that you can do is called this moment arm test. And this is particularly good for anchors at the corners, or if you only have one isolated anchor in a condition, you have like a roof bulkhead stairwell, and there's only one anchor up there. It's much better to do it for that. And what this essentially does is you're attaching a moment arm to this roof anchor over here. And then what you have here is a hydraulic ram, which is lifting the arm over here. And it's putting a force, and it's putting a very similar overturning force over here, which is kind of really mimicking what would happen in the field. And so I've shown a couple examples of that over here. And even though we haven't gotten too much into davit bases, the testing is done pretty similar. And if you're doing a certification, the requirements are a little bit different, and we really haven't had a chance to really dive into those as well. but they're done in a similar way with similar equipment. And I just wanted to show it that essentially what we're doing is something similar. In this case over here, we're testing the davit base itself, where the posts will go into. And over here on the right, sorry, I was using it on my slides. So over here, we have the davit base. And this is what we're testing over here. And then on the right photo, we're actually testing the outrigger arm. So normally this post would be vertical, this part would be overhanging, and then kind of you're hanging your bucket or your platform from this over here. So we're testing it against this to get that tension. And here we're testing the actual base itself. So now we'll go over what happens if we have an anchor, if we actually have to replace it. So the first thing you want to do is you want to evaluate the structural decking. What kind of system do you have to design that new anchor installation? Concrete structural deck is much easier to design than a steel decking system, which is much easier to design than a wood decking system. So these are some of the things to consider. It's not a one size fits all. These anchors really do have to be specifically designed for the substrate that it's going to be applied to, or that it's going to be installed into. If the structural decking is going to be concrete, then you want to make sure you get somebody out there to scan the deck for either post-tension cables or rebar to make sure you're not hitting some of the structural steel underneath in those. When you're doing these, I would strongly recommend coordinating the installation with a roofing contractor to maintain existing warranties. So for example, you have a 20-year warranty on your roof. To install these new anchors, you're going to have to make a hole and a cut out of them. And if you don't clear that with the roofing manufacturer or the original installer, if they also have provided a warranty, they're going to void the warranty. Even if a leak is caused by something not really related, they're going to find that as kind of a get out of jail free card. So you want to make sure you're coordinating everything with that. And just one little caveat I'll add to that is just because you're using the original installer doesn't mean that they have necessarily gotten approval from the manufacturer. And usually the roofer will give you like a 2 or 5 year warranty, something like that on their installation. And the manufacturer will cover everything from that 2 years to 20 years. So make sure that the manufacturer has given you an approved letter saying that they've reviewed it, or that the installer, person who's going to be doing the roofing work itself, is approved by them, and it won't void any warranties. When you're doing this, I would specify rapid setting materials. So the adhesives that you're setting the anchors into should be a rapid setting one. So that way the roofer comes first thing in the morning, they scan the deck, they make their openings, you install the anchors, and then you let it cure for 2 to 3 hours. And then by the early afternoon, you can already do your test and you can patch the openings within the same day. So you don't have to worry about any overnight rain or any weather kind of compromising that area. And then the other thing to do is, I would always recommend that if you're doing a roof replacement, I would go ahead and get this certified. So even if it's been like 6, 7 years, 8 years since your last certification, a roof replacement is the best time to get this stuff done, because making openings into an already made roof 2 years later is not an ideal situation for anybody. So conclusions. So schedule that annual inspection prior to the start of work. Usually early spring is the most busy time when we see this, but usually it'll coincide with whenever you're looking to do your window washing or your maintenance on your building. And schedule that certification, I should say, at least every 10 years. And I wanted to bring this one up in particular, just so that people are pretty much aware that, as I had mentioned earlier, in March 2012 was when this rule went into effect. So if you had your anchors installed during that time frame, that 2012-2013 time frame, then just kind of be aware that the certification, it's a more complex project. It's more complex, and it's going to cost a little bit more, and you just want to make sure that you're planning that accordingly. So, if you're used to somebody basically coming, walking, doing it, and then the next day the washer is coming to clean the windows, just plan a little bit more accordingly as you're moving forward. Hire a competent contractor that's following all OSHA and Minnesota rules. Yes, it's of course up to them to follow all of that stuff, and you don't want to be micromanaging or kind of prescribing means and methods. But at the end of the day, you don't want any incidents, and you want to make sure that you're hiring a competent person. Encourage the testing of the anchors to 5,000 pounds to make sure that everything's being followed. And then if you suspect any anchor may have been damaged or you have any concerns, reach out to a qualified professional as well. So with that, if you have any questions, let me know.
So looks like one came through here. Can you elaborate on rapid adhesive installation?
So that's basically just a material that will, a lot of times what you'll do when if I go back to that previous photo, basically what we have here is to set this plate, you'll drill your pilot hole, and then you'll put an adhesive in there, and you'll set that anchor in the adhesive. And depending on the product that you're using, that can cure. And when we say cure, it's basically, it's dried, it's ready to be used, it's ready to be in service load within 2 hours. Or you can have a product that can take 24, 48 hours. So if you use one that sets in that 2 hours, you can usually close that opening you can test and close that opening in the same day that you're doing the installation.
Okay, great. Another question was, can the PowerPoint presentation be emailed out? Can we get us that stack, and we can send it out if it's available?
Sure, no problem.
Oh, good. If there's any other questions. I don't think so. Thank you very much for that. That's a excellent presentation. Thanks for putting in all the time for it too. That was something I don't have much experience with, so this is excellent. Well, there's another one that came through here. The current building code requires the structure to resist a 5,000 pound ultimate load. If you field test to 5,000 pounds, how do you assure you don't permanently deform or fail the structure?
Sorry, can you just repeat that?
Sure. The current building code requires the structure to resist 5,000 pounds ultimate load. If your field tests to 5,000 pounds, how do you assure that you won't permanently deform or fail the structure?
In my experience, usually the structure can handle a little bit more than the prescribed amounts. I've never really considered that an issue, but I can, yeah, it really shouldn't be an issue. I need to think about that question a little bit more. Could you maybe send that over to me and I can reach out to the person?
Sure. Okay. Is there anything else? Type it in now. Otherwise, we can probably adjourn the meeting. Thank you, everybody, for attending. Thank you very much, Peter. Really appreciate it. That was, again, excellent. It's been a very fun season, so we're hoping to see you all in person very soon. Thank you very much.
Great. Thank you so much. Really appreciate it.